Hello students, welcome to IMS Gate Academy. In today's session we can discuss the problems which were asked in GATE 2020. I selected EDC questions of sudden and I would like to do those questions. Yes, this question was asked in the GATE 2020. What is given in the problem? Consider the recombination process via bulk traps in a forward biased PN homojunction diode. The maximum recombination rate is Umax. If the electron and the hole capture cross section are equal, which one of the following is false? Is asking to find which is false, which is untrue only here now. Option A, with all other parameters unchanged, Umax increases if the thermal velocity of the carriers increases. Like that, 4 options are given. Out of these 4 options, we need to find which option is false. But you need to understand every point clearly here now. Understand now. But here I would like to give one small formula. By using that, you can find out the what now, which is false. It becomes very simple to get out now. Recombination maximum, but here the point what you have to remember here now, intrinsic concentration, the maximum recombination Umax, if the electron with all other parameters unchanged, Umax increases if the thermal velocity of the carrier increases. Like that, it is given certain points only here now. And I wish to give maximum recombination rate, I wish to give like this now. Maximum, you will understand clearly. Maximum recombination rate. The maximum recombination rate is denoted by symbol Umax. The electronic devices and circuits, Umax is calculated by half into Ni into VTH into sigma naught into e power v by 2t 2vt into nt. Like that formula is applied to find out the Umax. Half into Ni into VTH into sigma suffix 0 e power v by 2vt nt is given here now. Here you need to understand the each and every point, then easily can identify which is untrue only now here now. VTH Ni is nothing but intrinsic concentration, everybody knows. Ni equal to intrinsic concentration. Intrinsic concentration, we can give the name. VTH is nothing but VTH equal to thermal velocity of carriers. Thermal velocity of carriers. And here the small sigma 0 is given, that is given capture cross section. Capture cross section it is given, and a V equal to applied forward voltage. This is a applied forward voltage. Applied forward voltage we can denote, and the VT is nothing but thermal equivalent of voltage. We can write it now. Thermal voltage. A thermal equivalent of voltage. thermal voltage, and still left n suffix t. That's given a name probability density of energy state which is present between EC and EV. So like that, just I gave the names of each letter only now. Now we can check here now. With all, because the electron and hole capture cross sections are equal, which one of the following is a true, false? With all other parameters unchanged, Umax increases if the thermal velocity of the carriers increases is given now. You check it in the formula. Thermal velocity is given a symbol of what? VTH. The VTH is increases. Umax also what is given? Increases only. Exactly, it is correct only now. That is increasing now. This is right. This point is a correct only now. This is true. This is true. And second one, Umax occurs at the edge of the depletion region in the device. But mostly Umax will not occur at the edge of the depletion region. At the edge of the depletion region means here you can understand clearly. Suppose you have taken P-type and N-type materials. P-type and N-type, I will explain clearly. Suppose the P-type and N-type I selected here. P-type and N-type material I have taken here now. This is a P, this is a N. But this is connected by the what now? Depletion layer is going to exist, depletion layer is going to exist at somewhere when the supply is given here now. But in the question, what is given here now? Consider the bulk transport, the forward bias PN homogeneous diode. If it is a forward, it is given forward bias. Forward bias means that must be connected positive. This is a negative only positive. This is a forward bias. But in the question it is given, Umax occurs at the edge of the depletion region in the device. Umax will not occur at the edge of the depletion layer. At the edge of the depletion layer, it will not occur. It will, where it can occur, at the center of the depletion layer only, it can occur only. That's a Umax occur at the edge of the depletion region in the device is a false. This is taken as a false only now. This is a false. Why it is a false? Or the Umax occurs at edge of the depletion region. Edge of the depletion layer means you can say like this only now. Understand now? Sorry. At the edge of the depletion layer means edge of the depletion layer. This is the edge of the depletion layer. This is the edge of the depletion layer only. Not at the edge of the depletion layer. Exactly, it occurs at the center of the depletion layer only now. At the center only possible. That's why, as per that point, we can say this is wrong only. Umax occurs at the edge of the depletion region in the device is a false. The reason is what means we can write here now. Umax occurs. Umax occurs. Where it occurs? At the center of the depletion layer. At the center of the depletion layer only. Center of depletion layer. Depletion layer I can write now. That's why I'm saying now it will be exactly at the center of the depletion layer only, mostly possible. Here only possible. Understand my point now. So that option is a wrong only we can say. What about the third one also we can check here now. What is third one given? Umax depends exponentially on the applied bias. You must understand now. We can see the Umax depends exponentially on the applied bias. Yes, exactly correct. The Umax here depends upon what? exponential function. Exactly correct only. That is also true. So this is a true only possible. This is also true only. The fourth one, with all other unchanged, Umax decreases if the intrinsic carrier density is, that means intrinsic concentration is decreasing means Umax also decreases. It's a correct only now as per this formula. That's why fourth point also we can say is a true only possibles. So which is false means option B is a false. So this is right only now. So once you know the formula, even this question was changed easily, you can attempt. That's why I gave this formula with explanation only now. Understand? We can go to next question now. Yes. This is one more gate question, 2020. A single crystal intrinsic semiconductor is at a temperature of 300 Kelvin. 300 Kelvin is given. With the effective density of states for holes twice that of electrons. The thermal voltage is 26 millivolts. The intrinsic Fermi level is shifted from mid-band gap energy level by 4 options are given now. How we can find this question? Once asked in the key. Very simple. A single crystal intrinsic semiconductor is at a temperature of 300 Kelvin is given now. Here given temperature is given 300 Kelvin, no doubt. And also given here with the effective density of states for holes twice that of the electrons. Twice that of the electrons is given. We can note down here NV is given, valence band coefficient is twice that of the electrons. That means twice that of the electrons means 2 into NC only. When you NV value is 2 times of NC is given here now. This is a valence band coefficient. Understand now? This is a conduction band coefficient only here possible. The thermal voltage is given 26 millivolts. VT I can put here now. Thermal voltage VT. I have taken as a 26 millivolts given in the problem. The intrinsic Fermi level is shifted from mid-band gap energy level by to the mid-band gap of mid-band gap energy level. It is shifted. What extent we need to find? Intrinsic Fermi level is shifted to the what now? Mid-band gap energy says now. How much it is shifted? That point is very important here now. What you have to know here, you have to understand one point here now. The Fermi level energy is what? How to determine Fermi level energy? The Fermi level energy for the intrinsic semiconductor is calculated by Fermi level in the mid, E mid. They will use the formula E mid gap, A mid gap plus VT into ln of thermal equivalent of voltage into ln of NC by NV. NC by NV. This formula is generally applied. That formula is applied. Fermi level energy of intrinsic semiconductor is calculated by E mid gap plus VT into log of NC by NV. Slightly we can change this one out. Now it is shifted to the what now? That EFI shifted to the what now? E mid gap. How much we need to calculate only now? That's why EFI minus E mid gap I wish to find. EFI minus E mid gap. Mid gap I want to calculate. That equal to we can write VT ln of NC by NV I can put here now. But in the question clearly given NV is nothing but 2 times of NC. I can write VT into ln of NC by NV is nothing but 2 times of NC is given in the problem. I can cancel this NC and NC and finally I am getting EFI minus E mid gap equal to how much? That value VT is nothing but thermal equivalent of the voltage 26 millivolts. I can substitute minus 3 and ln of natural log of NC cancel 1 by 2 0.5 it comes. Use calculator. Its value will be BTech EC का yes अक्षत जैन Yes, can you ask the question in English? I don't know Hindi. That's the problem only now. Understand? Okay, EF minus E mid gap equal to 26 into 10 power minus 3 log 0.5. Its value will be, this value will come as a minus 18.02. Minus 18.02 milli electron volts it comes. Milli electron volts it comes. This much value is possible. Milli electron volts possible. That means exactly we can say for the E mid gap, it is shifting to 18.02 only we can say. That's we can write one point here now. What we can write now? Fermi level shifted. Fermi level shifts shifted from where from it is shifting from mid gap band, mid gap energy level by 18.02 milli electrons volts possible now. That much change is possible. So finally change is that much is possible now. Which option is correct? Option D is correct, we can say. This is the right answer for this question only now. This is the right answer. Such a way we can tackle this question. But I would like to give one more question in your hand now. You can stand clearly now. One more EDC question the gate asked. This is one more good question. Anybody can tackle this question and they can give answer for this. You take some time and complete this question. How many students can complete this question? I will see. Anybody can do this question without my help? The question was asked from the solar cell. From the solar cell, it is given here now. From the solar cell. We can do here if you want. A PN junction solar cell of area is given. What area is given here? Area A is given as a 1 cm square. No problem. It is illuminated uniformly with 100 milliwatts per cm square. That we can keep it one side. Has the following parameters. Efficiency is given 15%. 15% is given. That is nothing but 0.15 efficiency for the solar cell is given. Open circuit voltage is given VOC. This is 0.7 volts. The fill factor also given in the problem. Fill factor FF. Fill factor is nothing but 0.8. And thickness is given. Okay, we can write thickness. Thickness equal to 200 micrometers. So, thickness equal to here given. Thickness equal to 200 micrometers only given now. 200 micrometers it is given. Yes. 200 micrometers is given. The charge of electron we know very well. Average optical generation rate is asking to find average optical generation rate. We can write average optical generation rate. I would like to denote by the symbol G. I want to denote by symbol G. Understand now? Is asking to measure the G value. If you know the formula from the solar cell, easily you can calculate it. It's not a tough task only you can say. So G value is calculated by just I short circuit current divided by ISc by Q into area into thickness. Q into area into thickness. By using this formula, average optical generation rate is calculated in the solar cell. But Q charge, you know, area, you know, thickness, you know. What is unknown means short circuit current. ISc is unknown only now. That current, how it is determined? That current is generally calculated by the formula. That is calculated by the formula. Eta equal to efficiency equal to generally, you know, formula. P maximum divided by P maximum divided by optical power. P maximum by optical power they will use in the solar cell. Or, but whenever the formulas of the PM and P optic if it is substituted, no, the simplified form of the equation comes as fill factor into ISC into VOC, open circuit voltage, divided by P optic by P optical, same P optical into area they will use generally. That formula is generally used only now. By using this you have to measure only now. But thereby unknown is nothing but the what now? ISC only here now. Eta value is given in the problem. What is given? If efficiency 15% is a 0.15 it is given. The fill factor is given in the problem 0.8. ISC is required. ISC is required in the problem. The VOC is given in the problem 0.7. But what is P opt? Optical power, how to get now? The illuminated uniformly with 100 milliwatts per cm square is given. By illumination of the what now? Light, we are getting that much value. The optical power is nothing but it requires in milliwatts here now. Milliwatts required means cm square we have to cancel. That means cm square you have to multiply 100 milliwatts. If you are multiplying by what area, directly you will get the optical power only. Thus we can write here now P opt is nothing but 100 into milli is nothing but 10 power minus 3. Its units is milliwatts per cm square only now. That value, if you are multiplying by area, I am going to get the optical power only. What area you are having now? 1 cm square, that I will correct now, into 1. Into 1 only possible now. And area is nothing but 1 only possible now. Area also 1 here now. And finally, you will get the ISC here. That ISC will be 26.78 milliamperes possible. That is a milliamperes possible. Now you can determine G value required. How to get that G? G is calculated by the value of G required here now. But the formula is given already. What formula is given here now? G. ISC is nothing but the 26.78. 26.78 milli is given, divided by what value? Divide by Q. Q is nothing but 1.6 into 10 power minus 19. 1.6 into 10 power minus 19 into what is given still? Into what? Area. Area is nothing but 1 cm square. I can put 1 into 1 into thickness is given, into thickness. Thickness equal to how much it is given? Thickness 200 micrometers now. Micro means 10 power minus 6, meter to centimeters means 10 power 10 square. 10 power minus 6 into 10 power 2 is nothing but 10 power minus 4 we can get here now. 10 power minus 4 it comes here now into 10 power minus 4. If you are using the calculator, this value will be 8.36. 8.35 into 10 power 18 is possible. 10 power 18 is possible. That much value possible. So here the given the option is 0, but what options are given now? 0.84 into 10 power 19. 10 power 19. Here also we are getting 10 power 18 or 19 we are getting now. 10 power 8.35 into 10 power 18 is given now. So 8.36 it comes into 10 power 19. So mostly if you are dividing by 10, what happens now? Dividing by 10, 8.3 into 10 power 20 mostly it is possible here now. understand now. You check it here now, these values, that's just use the calculator, mostly it comes, this is the formula only now, understand. Anyhow, we need to use by this way only now. So that way we can calculate the value only now. You check it, cross check again this value, because the value is this only now, understand now. The formula applied is this only here now. Then you will determine the value. You check it once again, this value, understand now. Anyhow, the formula which is applied here is the right only now. You will get the value. Once again, use the calculator and get the value and compare with the what now options now. 100% it comes equal only now. Anyhow, this is the way to find out the G value here now. So these are the problems in GATE 2020. I hope you followed. Thank you.